Hello friends, in this video lecture, we will see shortage of first scheduling algorithm. It is also known as shortage of next scheduling algorithm. It is non-preemptive scheduling algorithm in which the process which is having shortage of will be executed first. That is the theme of shortage of first scheduling algorithm, which is also known as shortage of next scheduling algorithm. It is associated with each process, the length of next process CPU burst when CPU is available, and it is assigned to the process that has smallest next CPU time or the execution time. Let's have merits of shortage of first scheduling algorithm. It gives minimum average waiting time. Shortage of first scheduling algorithm is easy to implement in batch system where required CPU time is known in advance. We have some demerits in ESJ scheduling algorithm. Processor should know in advance the length of next CPU burst. It is impossible to implement this shortage of first scheduling algorithm in interactive system where required CPU time is not known. Let's have one problem based on shortage of first scheduling algorithm. We have set of processes with given arrival time and CPU burst time, and we are asked to compute average turnaround time and average waiting time under shortage of first. We have taken same problem as we have seen in the previous video. We have processes P0, P1, P2, P3. 4 processes are there, and burst time, that is known as execution time, for each process is given. Here there is no mentioning of arrival time, means you have to consider that all processes are arrive at 0 or at same time. To compute turnaround time, we have to compute completion time, means turnaround time is completion time minus arrival time. And in case of arrival time 0, then turnaround time will be equal to completion time. Then waiting time is calculated with the help of turnaround time and burst time, that is turnaround time minus burst time. Let's see here. So we have 4 processes P0, P1, P2, P3. Which process will be executed first? P1, means as per algorithm P1 is having shortest CPU burst time. After P1 there is process P0 which has burst time 5. After P0 there is P3 which has CPU burst time 6, and after P3 there is P2, means P1 is the smallest process and P2 is the largest process. Means here CPU will be assigned to smallest process, that is P1 process. Means P1 will hold CPU for 3 units. After P1 there is P0. P0 will hold CPU for 5. Means total time is 8. Then after P0 next process is P3. P3 will hold CPU for 6 units. Total time is 14, and after P3 CPU will be assigned to process P2 which takes 8 units and total time is 22. So with the help of this NAT chart we can compute completion time. P0 completes at 8, P1 completes at 3, P2 completes at 22, and P3 completes at 14, and we have assumed that all processes arrive at time 0. Then turnaround time is completion time minus arrival time. That is 8 minus 0, 8, 3 minus 0, 3, 22, minus 0, 22, and here 14. Means all processes arrive at time 0. Then turnaround time equals to completion time. Waiting time is turnaround time minus burst time. That is 8 minus 5, 3, 3 minus 3, 0, 22 minus 8, 14, and 14 minus 6, 8. So what is total turnaround time? 8 plus 3 plus 22 plus 14, that is 47. Means average turnaround time is 47 divided by 4, that is number of processes, which equals to 11.75, and average waiting time is 3 plus 0 plus 14 plus 8, that is 25. 25 divided by number of processes, that is 4, which is 6.25. You can try this same problem by taking arrival time 0, 1, 2, 3. Means process P0 arrive at 0, P1 arrives at 1, P2 arrives at 2, and P3 arrives at 3, as we have taken in the previous videos. So thank you for watching. Have a nice day. In next video lecture, we will see priority based scheduling algorithm.